Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. Quadratic equations is a very important topic for class 10 students who are appearing in the board exams, and the multiple choice questions is the order of the day. Students have to be aware, what type of questions are asked as objective questions, especially multiple choice questions, and that's where preparation has to be very smart. So in order to help the students prepare well for their board exams, I have come up with this video in which I'll be discussing 7 important multiple choice questions of nearly all the topics. In subsequent time, I'll be coming up with other topics also. This is the video on quadratic equations. I'm sure you're going to enjoy this and learn a lot out of this. Currently, we have the best offers going on the CBSE class 6 to 10 worksheets. So after watching this video, if you feel that it will be beneficial for you to have a detailed worksheet on quadratic equations, then you can send me a message on WhatsApp 9896369963. I tell you the costing of those worksheets is just like nothing. The ebook of short tricks, the reasoning course, lots and lots of content available with us. So if you are interested in that, you can send me a message or on this WhatsApp number 9896369963. So let's see the topic in hand. 7 important multiple choice questions on quadratic equations. The first question which I'm going to take up is regarding the number of real zeros. Now there's a very important keyword here that is called real. If you ask somebody how many roots does a quadratic equation have, he will tell you that there are 2 roots of a quadratic equation because the degree of the quadratic equation is 2. But is it necessary that both the roots will be real? Not at all. The nature of the roots, whether they are real or not, depends on the discriminant, that is b square minus 4ac, this quantity of the quadratic equation ax square plus bx plus c equals 0. So depending on the nature of roots, the roots may not be real. That means there can be 0 real roots or there can be 2 real roots. So a quadratic equation cannot have more than 2 real roots. So the answer for the question is at most 2 real roots. It cannot have 3, 4 or 5 real roots, obviously, because the degree of the equation is 2. So if you are getting confused that how many real roots it has, then it's not exactly 2 because it can be less than 2. It cannot be at least 2 because it cannot be more than 2. It has to be at most 2 because you cannot have more than 2 real roots of a quadratic equation. Obviously, the fourth option is ruled out. So the answer for the question, at most 2 real roots. Let's see the second question. So here we have a quadratic equation 49x square minus 14x plus 1 equal to 0. And we need to find the nature of roots of this quadratic equation. How do you do that? You just have to identify the value of a, which is 49, the value of b, which is negative 14, and the value of c, which is 1, and find the corresponding discriminant, which is b square minus 4ac. B square is minus 14 square, minus 4, a is 49, c is 1. So your answer is 196 minus 49 times 4 is again 196. That means the discriminant is 0. And whenever the discriminant is 0, the roots of the quadratic equation are real and they are equal. That means there is, when you see the quadratic formula, you have a plus minus root d. So that plus minus root 0 or plus minus 0 is not going to affect the roots, and therefore the 2 roots of the quadratic equations are always going to be equal. So what's the answer for the question? A, real and equal roots. Very important question. The nature of roots is a very important concept for all the class 10 students. What's this? The quadratic equation, another one, 3x square plus 8x plus 9 equal to 0 has, again, he has given 4 different types of roots, the nature. So in this case, a is 3, b is 8, and c is 9. So how do you find the discriminant? You know the formula, b square minus 4ac. So just put the values, 8 square minus 4, 3, 9. So I can see that this is 64 and this is 12 times 9, which is 108. and this is going to be negative. I don't even need to find how much is that. 64 minus 108. I know that I'm subtracting a big quantity from a small quantity, and whenever you do that, you get a negative quantity. Whenever the discriminant of a quadratic equation is negative, then the equation will have no real roots. That means the roots of this equation are complex or imaginary, which is beyond the scope of class 10 students. So the answer is no real roots. Okay, now let's see the next question. If one root of equation 4x square, so here we have the quadratic equation given to us, 4x square minus 2x plus k minus 4 equal to 0, is reciprocal of the other, the value of k is. See, if you assume that one of the roots is alpha, then the other one is the reciprocal, right? 1 over alpha. So what will be the product of roots? The product of roots is always given by c upon a, and that c upon a, if you multiply these two, any number multiplied by its reciprocal gives you 1, right? So the value of c upon a is 1, and whenever the value of c upon a is 1, you can just put it there. C is k minus 4 upon a is 4 equals 1, and very simple linear equation in one variable there. K minus 4 equals 4 gives you the value of k as 8. So that is the answer for this question, 8. Very important question because it relates the coefficients of the quadratic equation with the roots of the quadratic equation. Next question concerns one of the roots is given to you, and you have to identify which quadratic equation has that particular root. Now the students spend a lot of time in this question, because they are busy solving all the 4 quadratic equations, which obviously is time consuming. But you should know how to check whether a given value of x, that is 2 in this case, is a root of the quadratic equation or not. So you just have to put the value of x as 2 on the left hand side of the given equation. If it satisfies it, it is a root. If it doesn't satisfy, it is not a root. So let's check A. If you put x equal to 2, it is 2 square minus 4 times 2 plus 5, right? So that is 4 minus 8 plus 5. This is not 0. So A is ruled out. Likewise B, 2 square plus 3 times 2 minus 12. So that is 4 plus 6 minus 12. That's minus 2. Again not equal to 0. B is also ruled out. C, 2 times 2 square minus 7 times 2 plus 6. That is 8 minus 14 plus 6. We get a 0 there, and there we go. The answer for the question is C, 2x square minus 7x plus 6. So you don't need to see the D part. So whichever equation satisfies the given value of x or the root, that becomes our solution. Let's see the next question here. X plus 1 whole square minus twice of x plus 1 equal to 0. Now he wants us to find the nature of roots again. 2 real roots, no real roots, 1 real root, 2 equal roots. So you can do it in 2 ways. One, reduce the equation to quadratic form and then find the discriminant. Based on the value of discriminant, you can find out the nature of roots. Or else, this question is quite easy because x plus 1 happens to be a common factor. So x plus 1 minus 2 comes in the bracket equals 0. So the equation is already factorized. You can see the equation is already factorized. So if you put them separately equal to 0, you are going to have the value of x as minus 1 and 1. And that means the equation has real roots, 2 real roots. No real roots, obviously both the values are real. 1 real root, no, both of them are real. 2 equal roots, no, they are unequal roots. So it is only 2 real roots. Likewise, the same type of question here, which is based on the nature of roots, and how do you find the relationship between the coefficients and the roots of a quadratic equation. Now it is given here that sum of roots is 3. So if you know that sum of roots is always given by negative b over a, then the sum of roots is given as 3. So you can find out the equation in which minus b upon a becomes 3. Let's check for the first one. Minus b is the coefficient of x here, and upon a is root 2. So negative negative is positive, and this becomes 3 upon root 2 times 1 by root 2, and that is not actually exactly 3. So the first one is ruled out. The second one, negative b is negative 3 upon a is 3, so that's 3 upon 3 1, again ruled out. C part, negative b is 3 upon a is minus 1, look at that, that is exactly 3. So the answer for the question is C, because negative b upon a, that is sum of the roots, becomes equal to 3 in that case.